There it is. Okay. So this first problem has what I consider to be 3 transformations.
Okay.
The order does matter, but do you have any of those transformations? Can you tell me any of those from what you see here?
Well, it moves right 4.
Okay, this is actually
Oh, no,
down.
it moves down 4.
Yeah, that's outside the function, so that's down 4. So that takes care of that one.
Shrink by a factor of 1/2.
Okay, and that can go in any order here. Shrink by 1/2. Is that language okay with your instructor? Do they like that? Shrink by
Yep.
1/2. Okay, perfect.
And
And then
then
that,
squared. Oh, no, it's a negative. So it's
yes,
it opens down.
it does open down. The way that's referred to as a reflection
Oh, reflection over the x-axis.
over the x-axis. Yeah, good. Okay, second one is a little bit easier. It only has 2 transformations. It is helpful to know how many kind of before you start, but we'll do some more if we got time at the end. So this one has 2 transformations.
It moves up 1, and it's a vertical stretch by a factor of 2.
Yes, and the way you said that is perfect. You want to include all those words. Factor of 2, not by 2. All right, so the third one here is in vertex form. And this is where you get those left and right shifts here. Snip that in here. There's make some space. Okay, so I see 3 transformations here. Up, down, left, right, reflection, stretching, compressing, all that's in play here.
And a reflection over x-axis,
Okay,
down 3,
okay,
and then to the right 2.
right, 2. Very good. Okay, so the order does matter here. Like if it were my classroom and you gave them to me in the order you gave them in, I wouldn't be happy because the order really can be easily defined. It's based on order of operations. It's based on when you evaluate this function. So let's say x were to equal 3. What would you do first when you evaluate, when you put 3 in for x?
3 minus 2.
Yes, and that's what corresponds to the right 2. Okay, then you'd square it, and then what would you negate it or subtract 3?
Negate it.
Right, and that's where that comes in. And then the last part is the down 3. So if your teacher doesn't care, doesn't mark you on that, no big deal, but it will matter someday. There's, when you're doing transformations at some point, you're like, you need to know the order.
Okay.
All right. Oh, even, odd, neither. Well, we were doing this a while ago. Do you need a refresher on even, odd, neither, or do you feel like you remember it from earlier discussions we had?
I feel like I remember it pretty well.
Okay. So you're going to evaluate d of negative x, whatever. Don't worry about the letter. Letter's not important, but you change x to negative x.
Okay.
And then
so
you actually
2 times negative x, so it's negative 2x. So it's either odd or neither.
So
So
is this
like,
the same as the original?
no, so it's neither.
Yeah, and when you factor out a negative, you get 2x plus 3. This is not the same as the original. It's the same question, literally. So you're right, neither. All right. You want to try number 5 for me? Let me know what you come up with.
Okay. So negative x cubed is negative x. So then it's either odd or neither. So factor out negative. You get negative 2x cubed. So it's odd.
It is odd, yeah. So there's kind of a shortcut for this, which is if both the variables are odd power and there's no constant, then it is odd.
Okay.
Which is kind of a heavy like if, but you can gain something by doing that if you want. Um so I don't know, like I guess like what happens is you do enough of these, you start noticing these patterns. The same can be said for evens. If they're both an even exponent, then it's even. So you will find that this one is not even because it's a squared and a one. It's also not odd because they're not both odd exponents. So essentially the shortcut is if it's even exponents, and there's no constant in both cases, no constant, even exponents, that's even, no constants, only, and I guess I should say it that way, only even exponents, only odd exponents, then it's odd. You still have to show your work though, of course, but it's a shortcut maybe to help you out there. Does that resonate with you? What do you think about that?
Yeah, that makes sense.
You'll see that here. It's 2x squared minus 4x, which is not the original. Factor out a negative. Negative 2x squared plus 4x is also not the original, so it's neither. All right, can we move on to 7?
Yep.
All right. You getting excited for the end of the school year?
Yeah.
I mean, we're really close, like 5 weeks, maybe
Yeah.
6, depending on how you look at it. All right. So it says use zeros to graph the function. Zeros are x-intercepts.
Yep.
So you're setting the function equal to 0. And this is why you did all that factoring, because you're
Yeah.
supposed to say, oh, I know how to factor this.
So let's factor out negative 3x. So then it'd
Good.
be x squared minus 4.
Okay. And then you keep going. You should look inside parentheses and say, like, well, is that
Yeah,
something I know how to factor?
that'd be x plus 4, x minus, or x plus 2, x minus 2.
Okay. So really good. Now you set each of these factors equal to
So
0.
it'd be 2, negative 2.
What about this first one? It's got an x in it.
Oh,
So if it's better, you can even put it in parentheses. Like if that makes
yeah.
more sense to you, the goal here is to get them all.
So
There's
then
3.
0, 2, and negative 2. Oh, so it's a cubed root function.
Right. And that's what I was going to point out to you is that the fundamental theorem of algebra says that there are 3 zeros. They may not all be real, which you'll find maybe next year, algebra 2, but you should be finding 3 zeros. 1, 2, 3, 0, -2, and 2. So there you go. You put your dots there, there, and there. Okay. How did your teacher want you to do the next part? Because there's actually 2 graphs that could work here. It could come high. It could do that, or it could start low and do something like that. Which one?
We haven't really done cubed root functions.
Yeah, well, that's why I'm asking, because there's a lot here. So here's what I would tell you to do. Here's the simplest way to do it. Let me get these back in. Is to pick a number, not -2, not 0, not 2, like x equals 1, and evaluate it. So -3 times 1 cubed plus 12 times 1. Could you give me that, please?
1 cubed, so it'd be -3 plus 12, so then 9.
9. So 1 and 9, so roughly there.
So that means it would have to start high and then go low.
Yeah, so exactly, and you saw that really well. Now this is not, to scale. This is just getting the shape, meaning it's
Okay.
like really rough. So you have to know that what both of them look like, and then figure out the one that matches.
Uh,
But that's only for cubics. For quadratics, which is number 8. For quadratics like this, you have to just factor. Now, one of the things we've never talked about, I don't believe, is that when there is a negative in front, you generally do factor it out just because it's so awkward. You don't have to, but I would strongly recommend doing it and then factoring this here inside.
then you have 10x squared or negative 10x squared and then 3x. Like,
So this one is called grouping. You have to take this 2 times -5, which is -10. And then you're trying to find 2 factors of -10 that multiply to
add it
+3.
and multiply. Oh, wait, then multiply to +3.
They multiply to -10, but
Oh, but
add
add
to +3.
5 and 2.
One's got to be positive, one's got to be negative.
-2, 5.
-2, 5. Now, which are you going to pair with the 2x squared? Are you going to pair the -2x with that or the 5x with that?
-2.
So 2x squared minus 2x plus 5x minus 5. That minus is still on the outside. So now this is where you use grouping. Okay, you figure out, well, what's common between 2x squared and
And
-2x?
factor out 2x and you get 2x times x.
A little
'Cause-
more, because you got to get 2 terms.
Oh,
So-
so that's -2. X minus, oh, 1, x minus 1,
Okay, and then you also write that over here, x minus 1, same
Yeah.
thing,
and then 5.
plus 5. And this negative is still it's still on the outside there. Okay, so then the inside becomes 2x plus 5 because you group those together that are not x minus 1 or not this thing in parentheses here. Negative still on the outside there.
Then subtract 5 and then divide by 2, so -2.5.
Yep, -5/2 or -2.5.
And
What
then
about the other one?
1.
+1. Okay. Okay, now question is, well, which is it? Does it go, down? Or does it go?
It opens downward because
Or
it's negative.
Yeah, I agree. Now this is where, like, for me, see, I feel like you can do a bit more here, but like you can find the y-intercept. I know it doesn't ask for it, but like I think it's sloppy to just kind of connect them because you can easily find the y-intercept. That's when x is 0. H of 0 is what's the y value when put 0 in?
And then 0, 0, 5.
Yeah. That doesn't work though. Why do we really not? It seems like we missed something here. 2x squared plus 3x minus 5. Okay. 2x, x minus 1, 5x plus 5. It's just it's a weird scaling, I guess. Because the vertex is supposed to be midway between the two intercepts here.
Maybe put it in Desmos and see what they say.
Yeah, that's a good idea. Do you have it pulled up?
Yeah.
Why don't you graph that for us and let me know what you see here, because it's visually not looking right to me, even though I feel like all the numbers here are good, nice and solid.
What is it? So -2.
Negative 2x squared
How do you
minus
put
3x
how do
plus
you-
5.
How do you put squared in Desmos?
So there is a calculator. There is one option. There's a little a squared. You hit
Oh,
the
I
calculator
found
button,
I
or you
found
can
it.
use the caret Shift-6 on a.
Yeah. So -2x squared minus 3x.
Yes, minus plus 5.
Minus 3x plus 5. No, it's just weird scaling because yeah, the
Yeah,
y-intercept is still 5.
it is correct. It just it kind of doesn't look like it, but that's the problem when you use different axes scales. It just doesn't look right
Yeah.
at some point. But okay, good. Any questions on that before we move on here?
Nope.
Okay. All right, let me grab another question for us to look at. Oh yeah, okay. So 9, 10, 11, 12. These are the whole, is it linear? Is it quadratic? Is it exponential? There's kind of a progression. It's kind of like the whole even, odd, neither.
Okay.
So your progression should be, and they talk about this in most classrooms, is called a first difference. So the first difference, and you just create another place for this. The first difference, you take this 12 and subtract 10, 14 minus 12, 16 minus 14. And you're supposed to show it. You're supposed to actually write those down. Usually just put them in between there, like 2, 2, 2, and 2. And if it has a common first difference, it is considered linear.
Okay.
So it's got to be exactly the same each time. Do you get a note card for your exams? I really can't remember what you told
No,
me.
I don't.
Okay, so you got to commit that to memory here. So sometimes you can just visually see it does not have a common first difference, but that doesn't mean you shouldn't calculate it. You should calculate it each time because you may glean something else from that. Okay.
It's exponential.
Yeah. Now this one, the common difference doesn't help because when you do the second common difference, it's also not consistent. For exponentials, you have a common ratio. What's called a ratio here, and it's either multiplication or division. What is that common ratio?
You're dividing by 2 every time.
Yeah, so you can even show that divided by 2, and so on.
Okay.
I'm shocked you guys don't have to write the equation, but yeah. All right, so for number 11, here. Again, the appropriate thing there is to find this first difference. -5 minus a -4. Okay. -4 minus a -5. That's the appropriate way to do it here, even though maybe it doesn't seem necessary. We'll see that here in a moment. -5 minus -4 is -1. -4 minus -5 is 1. -1 minus a -4 is 3. 4 minus -1 is 5. That's the first difference. Now, what's really cool is if you take a second difference here, 1 minus a -1, you get 2. 3 minus 1 is 2. 5 minus 3 is 2. If the second difference is common, it is quadratic.
Okay.
And the same thing works for like a cubic or quartic or fifth degree or really any degree polynomial. You can figure out any degree polynomial by using this difference method, polynomials only.
Okay.
So you can imagine how before there were, technology calculators, that this is a way that someone could figure out the order of a polynomial. Now,
Okay.
like when I look at this, there's no show work, right?
Yeah.
So the other way you could do this is notice that, see how there's a repeat here?
Yeah.
The only time you get a repeat is for this type of function, because it either, either has it here or here, or here and here. That's why we know this is a quadratic by just looking at it.
Okay.
So when you look at 12, can you tell me what it is without doing any just kind of inspection of the numbers like you were doing earlier?
Quadratic.
This is a quadratic. You can also kind of see it either hits a min, like at that 3, and comes up. There's another way to do it, the repeat, first difference, second difference, and so on. All right. So that's everything from the, I'm missing, just so you know, I'm missing 13 and 14 and 15. In case you want us to really do those.
Okay, let me look at them, see what they are.
If you want, you can quickly send them over and I'll incorporate them into the lesson today or not.
And it's just positive, net positive and negative associations with a what's it called? Scatter plot.
Okay.
So it's pretty easy.
Let me just give you the information that is very common that you probably already know, but sometimes it's good to say the obvious out loud. There are two types of association. There is positive, kind of everything's going up and to the right. There is negative when everything's kind of going down and to the right. And then there is no association when the data is just sort of all over the place here.
Yep.
There's more you can say about this. There's things like the,
Strong linear association.
yeah, and there's even more than that when you get into even higher courses, but essentially you want to know how well correlated your data are. The first thing you do in any sort of situation where you have data is you plot it and you hope to glean something from that. Like, hey, it goes up, goes down, it, whatever it does. All right, moving on to 16 now. All right, so this is, it says for this one, it says to find the zeros of the function, you're setting it equal to 0. The
Yep.
type of factoring that is GCF.
And factor out -2.
Yeah, why don't you go ahead and do that for us? When you do that, you're going to get one of these other types, most likely a perfect square trinomial, and A equals 1, a grouping, A not equal to 1, a grouping. And then there are a bunch of other beyond here, but this is sufficient. How are you doing on this one?
So I got 6 and -1. And then it should be
You've got some signers there. Is this what you have inside parentheses?
yeah.
Okay.
I was talking about
I'm sorry. This is correct.
the
This is wrong.
factors. It's like
5x.
x squared -1 plus 5x. Or
So what
x, I should probably do x squared plus 6.
so it's not squared anymore. When you are reducing this to two binomials, it's x to the power of 1.
Oh, so it's just x plus
Yes.
6
Yes. And then,
plus. Or is it x plus 6x or just x plus 6?
so it's just the number in this case.
Okay. And then and then x -1.
Okay. So this is great. I mean, this is like you're almost there. You got to get off the off ramp and get to the final destination here. What are the zeros? That's really, they're looking for a box here where you just put the zeros in.
-6 and 1, because I don't think the -2 matters anymore.
So it's the reason it doesn't matter is it does not have an x. It's
Yeah.
not a factor because there is no x with it.
Okay.
Okay. All right, very good on that one. Grab the next one here. Actually, let's do one kind of more like it. Let's go to 18. 18 is what you were thinking of. We'll come back to 17.
Okay.
So this one, because it's a power of 4 here, when you factor it, it does become a power of 2 in here. It's x squared and x squared, but it's always a reduction by 2 from this exponent. Is that okay? Is that clear?
Yeah.
Okay, so now you're looking for two numbers that multiply to 4, but add to -5.
Squared, squared. Then don't I multiply the -5 plus 4 together?
No, you multiply two numbers to get 4 and add to,
Oh, and add to -5,
yeah.
-4, and -1.
Okay, so those are the numbers that go inside here.
Okay,
Now you look at each of those individually.
so the x times, so there's gonna be 4 solutions. So x out, so it'd be x times x minus 1.
These are both difference of squares.
Oh, so x minus 1 times x plus 1 times
Okay,
x minus 2 times x plus 2.
yes. Okay,
What would
but you're
that
not
look
done.
like on a graph?
So a quartic typically will come, it makes sort of like a W, or the other direction, it has a W shape.
Okay,
M or W. But before we get to that here, give me the zeros. What are the zeros here of this? You've got the
1,
factors.
-1, 2, -2.
Okay, very good. All right. Now the better case here is something like 17, where it's already in what's called factored form. Okay, so you got to be super comfortable with, what form is it in?
I don't even think I have to do anything with this, right? I can just find the zeros.
You set the 3x minus 1 equal to 0 and the
Yeah.
2x plus 7 equal to 0.
So 1/3 and -7/2.
All right, fantastic. Now for a problem like 19 upcoming here, problem like 19, you have to factor first before you can set them equal to 0.
Okay. So
So,
it'd be factor out 2x, so it'd be x squared minus 9.
okay,
And then it's 2x times x minus 3 and x plus 3.
good.
And then you still have the 2x.
Okay, so
So
you got to
then
set
it's,
each factor, anything
yeah,
with
so
an x
it's
equal to
gonna be
0.
0, x equals 0, x equals 3, and x equals -3.
Okay, very good. All right, so we're up to number 20 here. Let me grab the graph and then we'll do kind of one at a time here for these. Feels like you've been working on this stuff for a while now. Meaning like I just remember lessons from maybe before you went on spring break on this stuff. So actually, let me switch this up. It's usually better if this is on the left, questions on picture on the right, graph on the left here. Okay, let's start one at a time here. Domain. Domain refers to
All
the
real
x
numbers.
values, all real numbers. Yeah. Now, how are you guys denoting that?
ARN.
ARN. Okay, that's really bad notation, but that's okay. That's not you, but just that's not the right math way to do it. So but you'll see a better way, I hope soon. Range, about range here.
Y is less than or equal to 8.
Yes, it's the y value of the vertex. So we got that, we got that. Zeros. What are the zeros here?
1 and 5.
Now, are you supposed to say like x equals 1, x equals 5? Are you supposed to write them as ordered pairs, 1, 0?
Probably ordered pairs, yeah.
It's very unclear from the way this is written. All right, well, you got them all.
Yep.
Okay, so before we do part B, which is to write the function in standard form, what part B is really asking you to do is first, this we'll call this A to B, is to write it in vertex form. Okay, so vertex form is A x minus h squared plus k. That's the first option. The second option is to go into factored form. You just can't go straight to standard form. So factored form is a x minus b, x minus c. Typically, you're doing vertex form to standard form. Do either of those look familiar to you?
Factored form, I guess.
Okay, so
Usually we write it, I think, in slope intercept form and then convert it to standard.
so slope intercepts for a line. This is a quadratic. Slope intercept form does not apply here. The vertex form would come from using this point up here, 3, 8 for h and k. And then you'd use another point, either the 1, 0 or the 5, 0 to find a. We were doing that a bunch before. Factored form allows you to use these two zeros, 1 and 5, as your b and c. And then you use another point to find a. They're both good. You know, what do you what do you see?
Probably factored form.
Okay, let's do it.
The best.
So this is x minus 1, x minus 5. Okay, and to find a, we're going to use point 3 comma 8. So 8 is your y. X is 3. So I want you to solve this for a, please.
So a, so 8 equals 2 times negative 2 is 8 equals negative 4a. So a equals negative 2.
And is that consistent with the graph? Does that correspond to what's happening here? Think about the minus sign.
Probably.
Okay. So when a is less than 0, it opens down. A greater than 0, it opens up.
Yeah.
And that's what I was asking, because you want to know that like your answer is somewhat reasonable. Like, okay, yeah, that works. So now this goes in here. So it's y equals negative 2, x minus 1, x minus 5. Now we can write the equation in standard form. All right, so standard form is, if I can get my cursor, ax squared plus bx plus c. How does that differ from what we have here?
Well, x. You just have to plug it in differently.
Well, notice that it's written out as a term with x squared, a term with x, and a term with c, whereas here these are factors.
So would we just multiply it back?
Yes.
So
I recommend foiling, and then you're going to multiply each term by -2.
Okay, so then x squared, negative 1x, 5, and negative 5x.
Okay. Give me your final answer whenever you got it.
Y equals negative 2x squared. And negative 1x minus so plus 10x.
Okay. How did you come up with that?
Oh, plus 12x, I think.
Okay.
Yeah. And then plus 5.
Okay. The last term is also not correct.
Oh, wait, no, because I have to multiply it by negative 2. So then minus 10.
Yes. I get the feeling you don't have any paper in front of you to work these out. And some of them I agree, you can just look at them, but others you really should have have something here in front of you to at least do some work on. All right, now unfortunately for C, we would have been better off getting vertex form. And the reason is it wants transformations in C. All right, so when it says compare to the graph, that really means transformations. All right, now just to save some time here, when you have a graph in the form x minus h squared plus k, and you have ax squared plus bx plus c, and if you have a x minus b x minus c, guess what's the same in all of them?
X minus some, oh, the A.
The a. Okay, so that's really important here. Like, you don't have to recalculate a. You already know that a is -2. You also know the vertex. The
So
vertex
X
is,
minus 8 or minus 3, yeah, because it's the opposite of whatever it is.
yes. So even though it's kind of like, I got to write another form, you kind of already have it because a is the same in all three.
Okay.
Kind of neat. Now there are 1, 2, 3, 4 transformations here. I'll take them in any order.
Oh, so up 8
Okay.
to the right 3. Reflection over x-axis. And then vertical stretch by a factor of 2.
Very good. Keep in mind that 2 and 3 could be in any order.
Yep.
Doesn't really matter. That's not always true. Good. Okay, so kind of a lot there. On a real test, maybe that's broken up into multiple problems. Not really sure. Okay, number 21 here. Finding the vertex first. Okay, vertex first. So this is in vertex form. I'll write the format below it. I can get that to come up. There it is. So the vertex is at h comma k.
Yep. So it's the opposite. So then -4, -2.
Good. All right, 22 is somewhat similar here. 22 is somewhat similar. It doesn't have anything written off to the side.
Yeah.
Okay, but we can add in,
+0.
yeah, so what's the vertex now?
-1, 0, or 1, 0.
Good. Okay, now that we've got that down, we can go back and do what's called the axis of symmetry. And this is always x
It's just
equals,
x equals, yeah. So then -4.
yes. And this one is x equals 1. Really good. Okay, now that's if it's in vertex form, right? So there's like all these problems where if it's in like vertex form, like certain things are easier. If it's in standard form, certain things are easier, or you have to use different approaches. So you almost have to change your thinking, kind of like when you go to a foreign country and you're trying to speak the language. It's like, wait, there's things that are a little bit different here. This one's in standard form. Okay, ax squared plus bx plus c. The vertex is -b over 2a. It's better to use formulas.
Okay. So then -b, so 6 over 1. So then 6.
Okay, very good. Now that's only the x coordinate. To get the y coordinate, you got to put 6 back in.
Yes. So then 1/2 of 36 is 18 minus 36 plus 10. So 18 plus 10, -8.
Okay. So what this allows you to do is find that with these formulas, and you don't have to, but that's really the best approach. What's the axis of symmetry?
6. X equals 6.
X equals 6. Yeah, this one has to be an equation. Whereas like when you're writing a 0 and you say x equals 0, that's not really correct. It's better to write as an ordered pair. This one has to be an equation. Okay, same thing here. Why don't you use formulas? Give me the vertex of this, please.
Okay. The vertex of -b. -18 over 4/3. Calculator.
Yeah, absolutely. Please.
18 divided by 4.
I do want it as a fraction though, even with using the calculator.
Yeah,
Which you should be able to do.
18 divided by parentheses 4 divided by 3. That's 13.5 for x.
It should be negative 13.5. Check your
Oh
sign
yeah,
on that.
because it's negative b. So then plug that back in. So second answer squared is 182.25 plus 18 times 13.5. 400. I got 425.25.
So there's a sign error, not a sign error, there's a numerical error there. What kind of calculator are you using for this?
TI-84.
Okay. Your TI-84 will accept this completely.
I don't know how to do fractions.
Just the fraction, okay, so let me show you how to write this. You write 2/3
Okay.
minus 13.5 caret 2 plus 18 minus 13.5.
Minus 13.5 minus parentheses squared plus 18 times negative 13.5 negative 121.5.
Yes, that's correct. Do you typically get the calculator for the whole test?
Oh, I know what I did wrong. Yes.
Tell me, what did you do wrong?
I didn't plug in the negative. I plugged it in as a positive.
Okay, yes. So one of the things to do with the calculator is always do the calculation twice to confirm it. Doesn't take that long. If you get into the real world, you always double check, triple check, things like
Yeah.
that. So stakes are a little bit higher in there. All right, so we got 25 here. Here we go. All right, so in these story problems, these word problems here, there's typically only a couple of things they ask you for. They typically ask you for up here at 1, like, and there's 2 questions. It's either like, where is it? What is it? Or they ask you for something happening at 2, like, when does it hit the ground? Okay.
Yeah.
So when you read this problem here, when it says how many seconds will it take for the shell to hit the ground? That's 2. They're asking for 2 there.
Yeah.
What
So
is the
then
maximum height of the shell?
x-intercept, so y equals 0.
Yes, exactly. And then for the maximum height of the shell, they're asking for the y value of the vertex. Okay. So you can graph this. Now, are you allowed to actually graph this on your calculator, or do you just set it up and
I'm not allowed to have a graphing calculator on the test.
but you got a TI-8384. That's the graphing one.
Yeah, this is just the one I had. I'm not allowed to
Okay.
actually graph on
Okay.
it.
Got it. Okay. Yeah. So for the second one there, you're setting it equal to 0. You want to solve that for us, please?
Equals negative 16 times x squared minus 49 plus 784. 0 equals negative 16x squared plus 784 plus 784. Sorry, 0 equals negative 16 x squared 1568 divided by 6 negative 16 negative 8 negative 98 equals x squared. So I got approximately, when I'm rounding the nearest whole number, I got like 10 seconds-ish.
This one can be done exact. So let's talk about that. You subtract 784 from both sides.
I multiplied the 16, I distributed first.
You can't do that because of the square, and that's making more work for yourself.
Oh,
Because you actually have to FOIL this, and then you've got multiple terms with X. So that's good. It's good that we saw that in practice here. Divide by minus 16. Okay, you should get X minus 7 here squared equals 49, I believe. You want to check that? 784 divided by
yeah, 49.
yeah, and you take a square root of both sides. So it's X minus 7 equals plus or minus the square root of 49. X minus 7 equals plus or minus 7. Add 7. So it's 7 plus or minus 7, 7 plus 7, 7 minus 7. So there are your two possible answers. It is the first one because 0 is when it took off.
Okay,
All right. To do what is the maximum height of the shell? Notice it's already in vertex form.
so I
And
just
this,
substitute x in for, oh,
you already have it because it's right. It is the maximum height there.
okay.
All right, so we got one more problem to go here. We'll have to pick that up on another night here. Again, it's either finding one or two in terms of what you're doing here. But that's all the time we've got for today. Braeden, your exam is on Monday, is that right?
Yeah,